going here. Welcome everyone. Good morning, good afternoon, wherever you're joining from. Thanks for attending our monthly webinar today. My name is Caroline. I'm with Wavefront. And before I turn things over to Mike, who will be our presenter, I just want to take care of a couple quick housekeeping items. So first of all, we will be recording this session and we'll make it available to everyone tomorrow. We'll send it out in an email. So you will have access to the recording. Second item to note is that after the presentation and demo, we'll end with a Q&A. And how we will do the Q&A is we will use the chat feature. So at any point throughout the presentation, you can type your questions in the chat box. And then at the end, we will try and go through as many questions as we can. So if you have any questions, type them and it'll send a message to our panelists. And with that, I'm going to hand things over to Mike Eisenberg, who's a systems engineer at Wavefront, and he will introduce himself and get going.
Hi, everyone. My name is Mike Eisenberg. I'm a staff systems engineer with Wavefront, part of VMware. And we're going to take you through a Wavefront overview. Hopefully you've got questions already, but definitely, as Carolyn mentioned, please put the questions into either the Q&A or the chat. The Q&A or the chat. The controls are on the bottom of the window that you're viewing. And we definitely want to answer all your questions that could come up. So let's get started. So what is Wavefront? Wavefront is a SaaS-delivered high-performance metrics monitoring and analytics platform. So it allows you to, and what that really means is it allows you to visualize applications through metrics and traces. So we can actually understand what's happening inside your applications. We can identify trends, troubleshoot faster, and obtain specific alerts on anomalies. But the idea is not to get 1,000 alerts that don't mean anything, but to get the one alert very specifically that matters and you can actually take action on, whether it's a scale up, a scale down, or some other remediation process for fixing that particular problem. The idea is to spot trends, what's going on inside the environment, alert on anomalies, and then visualize your application at scale, being able to see what's happening with the application, understand the actual lifeblood of the application. So it's got a UI and an API backend, fully REST API. It's got a full UI for being able to work with the metrics. It also has advanced analytics. And what that means is we've got a ton of math that's built into the product. Most systems or monitoring systems have 6 or 8 different calculations that you can affect and change. We have over 120 mathematical formulas that are built into the product and are pretty easy to use. You can make them really complex, but we start them out with wizards and with a query builder, and I'll show you all that through the demo. We do a really great job at metrics collection and storage. We're super scalable. We never roll up your data. We always have raw format. We can give you averages and sums and totals and things like that as well. But the idea is that we start with your raw metrics and we never roll them up. And we can ingest a tremendous amount of metrics. We never have an issue bringing metrics in. We've done over 4 million points per second, and that is per second, not per minute, like most of our competitors talk about per minute. But per second, we're being able to do a sustained 4 million plus metrics per second. And we proved that out with in production, scaled up to support that really nicely, and we were very, very proud of that accomplishment because there isn't anything else on the market that can really do that. The second part of that is not only being able to bring the data in, but be able to visualize that data back out to you. And being able to do that round trip in a very short period of time is what Wavefront's all about. So if you think about how monitoring and metrics fit into a modern monitoring stack, how do metrics compare to logs and logs compare to APM? If you think about it, metrics are the in-flight. You know, we're going to use an airline analogy here. Metrics are the telemetry that's telling you where you are in your flight. How is the application running? Is it up? Is it down? Is it putting through data at the rate that it needs to, or it was yesterday, or similar time frames in the past? Is it still performing well? So that all the information about what I need to run right now. Logs are really important. Don't get me wrong. Logs are super important, but they're not as important as metrics because they're used after the fact. After I've had a crash or I need to find out what went wrong during a particular flight, I go back to my logs. It's kind of like the black box. I'm going to go back and figure out what happened during that incident and be able to drill down there. But metrics are small, they're fast, I can find out what's happening right away, so I can actually do things in flight or in process to affect what's going on inside the environment. APM is great as well, but it's really the schematics of how your application is built. Is it all connected the way you expected it to be? Is it working? Does it flow from one component to the next component to the next component as well as it should? And we give you some of that with our tracing capability, but we don't give you the full capabilities that an APM would be, being able to track every API call, every data bit point in and out. And most of our customers have moved from a log heavy or APM heavy view of the world to a metric center view where they're keeping metrics for a year to 2 years, they're keeping logs for 3 weeks to a month, and they're keeping their APM data for a week to 2 weeks. The reason is that it takes such a long time to get the data out of the logs in the APM that, and also the data becomes stale very, very quickly. So if we're looking at how Wavefront differs from your traditional monitoring tools, things like SolarWinds or vRealize Operations or a variety of those are really traditional IT managed tools. You know, the group that is running those tools is looking at the data. They're working with that data. They know whether they're up, they've got the right capacity for their environment, and they're really looking at supporting the overall infrastructure. With Wavefront, we're really looking at DevOps environments where we're building applications, we're instrumenting those applications. They're business critical lines of code so that I can actually understand and see the data that's flowing through the environment. We've got lots of successful customers, Intuit, Workday, Groupon, Box. These are all very familiar names to anybody who's used an internet-based application. These are big customers using who have thousands of employees that are looking at this data on a daily basis. With traditional monitoring tools, you usually get 10, 15. One of my largest customers, one of our largest financial customers, they've got about 150 people looking at metrics. You know, every one of those ones on the top there have over 500 people looking at metrics on a daily basis to understand how their applications are running right now and do they have issues as they're rolling out new applications and new code. And I'll actually do some demos around that as we go. Last thing I want to show you is this slide. We can collect data from just about anything. We're Wavefront, we're a SaaS-based environment, so we're out on the cloud. That's where our main storage is. That's where you go to query us. We can pull data from other cloud services, from a variety of all the cloud services, whether it's serverless or Kubernetes or any of their other database or compute services. We can pull data in from those services. We also have an on-premise capability. So we have the Wavefront proxy. That proxy is usually in your data center or your section of the public cloud. And it can pull data using agents, using metrics libraries built into the application code. So we can pull data from applications themselves. We can pull data from logs. We don't collect the logs themselves, but we'll count a certain type of log message, or we can parse a log message to pull a metric out of that message. So again, we're not going to keep the log data. That's for other tools, as we mentioned. But again, pulling the metrics that are important out of the log data, we can do that as well. The last thing we do is we can pull data from other metric sources. So whether it's other agents or other tools, we can go right against things like Zabbix or Nagios, go right against their database, query the database, pull the information in, and correlate that data. Now, the nice thing is I'm pulling in all this data because, again, my applications might have internal, external, multi-cloud, super hybrid, whatever you can think of, you're going to have that different types of applications. Wavefront can pull all of that together into a single view, into a single ability to be able to understand what's happening with the application, and then drill in to figure out what's wrong, where is it wrong, and how to fix it. So with that, I'm going to jump out of the slides here, and I'm going to go into the demo. So what we're looking at here is a representative application where I've got my application running here, and I can see that I've got my key transaction, key performance indicator. My number of transactions per second is going down to a point where I get an actual alert on it. I can hover over the alert, and I can see that it's app 5 is causing the issue. I can also slice and dice this data into different dimensions. So I'm looking at all the data now, but I can actually break it out by customer stream. This way, customer stream, I can see all the customer streams, whether it's wholesale, retail, or it doesn't matter, or partner data streams that's all being affected. And I can also break it down by application server. So what we've done with this is we've actually taken that KPI and we've broken it, assigned tags to it so that we can slice and dice the data different ways to show what's relevant. We can also use that to group things together. So if I'm looking for all my application servers, I can tag all my application servers, and I can look at those and compare those. And that's actually what I did here, where I'm actually assigning the metrics, tagging them with the app server name, and I can actually break things out by the application server itself. So what we've got here, since we know now that this is app 5, I'm going to switch my context of this dashboard, this kind of busy chart over here on the right. I used to call this the world's ugliest chart, and my manager said, no, that's not a good way to describe it. You should describe that as the busiest chart. And I'm like, okay, it's semantics, but whatever you like. So here we've got that same KPI, transactions per second, inside there. But what we also have in this chart is every other metric that would be an indicator of performance. So I've got memory, I've got storage, I've got network, I've got application, I've got database, I've got 85 other metrics in here that may have something to do with the performance of how we're doing on app 5, on my application server 5, and what could be affecting this. So what I'm going to do though, instead of looking, because you don't know what's wrong when you're starting out to figure out a problem, you want to find out, and what I'm going to do is correlate against that transaction count. Correlation is one of our standard functions that are built into Wavefront. And what we're going to do is correlate against that KPI. So here's my KPI, and what I've got is 3 other metrics that are working in lockstep, that have had something else go wrong with them in the same time frame, in the same range that we had the transactions falling out. So what I've got here is I've got my free memory going down. I've got my application app log error messages increasing, as well as I've got my garbage collection routines increasing as well to try and recover some of that memory that's shrinking. So I can see that right here I've got an application problem. So what I'm going to do is, I'm more of an operations guy, so I'm going to say, hey, I better send this over to the application owner. So down here on the right, I've just clicked on this hot link. And what I'm going to do is send it over to them, and I can send it in chat or an email. I'm just going to paste it right here into this browser window. And what I'm brought back with is a point-in-time view in context of how I was looking at the data. So notice here that we've got the transaction data. The KPI is still broken out by application server, and I can see app 5 still falling down. And I've already got my correlation applied to my metrics, so I know which metrics are the issue. But it's not just a picture. It's actually a live view of the data. So if I'm the application owner and I need to drill in a little bit further and figure out what actually started first, and I can see that my application error log messages increased first, and then I started to have my my application memory, my available memory went down, and then the garbage collection routines started up. So I can really see the sequence of events to understand what's going on. And as the application owner, I can confirm that this is something inside the app that's gone bad. And now I can actually, at this point, go in and go to my external links, jump into my logs, whether it's Splunk or vRealize Operations or Sumo Logic or Network Insight, whatever other tools I happen to see, I can also drill into those. So I can again do my hot link right to those, or I can continue on, send another link down to the developer to say, hey, you should take a look at this, see what's going on inside the application. So that gives you an idea of how we can use this at the dashboard level. We've also got a, well, this chart is a representative of a common problem. This was a set of data that we borrowed from a customer because this was so classic. What we have is a series of anomalous data collection points where these are going to trigger false alarms, false positives for a negative event. And what the customer actually had a problem, they actually had an outage in their service for about an hour just after 1:30. So they had this outage. Right about here, they got notified by Twitter. Their customers were complaining on Twitter that their service wasn't available. But the operations team was so numb from the anomalies or the error messages that they had before, the alerts they had before, that they really missed this one completely, and unfortunately were notified by Twitter. So I'm going to show you how we can actually, by using some of the math inside the environment, to get rid of these anomalous alert. So what I've got here is the query, and I'm set up in my query builder. And what I've got is my actual metric, and I'm looking at test.http.request. Again, we've changed the names a little bit to protect the innocent. So, we're looking at sources is everything going to this DNS name. So everything through this DNS name is the source of that. Now what I'm going to do is I'm going to copy this, and this is one of our nice ease of use features, is again, I'm just going to copy the query, and it's going to build a complete another one down here. And what I'm going to do is I'm going to add in a function. Most systems today have the ability to apply a moving window. Moving windows are good to smooth out anomalies. So I'm going to take the moving average, which is what all the other tools use, and I'm going to add in that moving average. The moving average by default is 10 minutes. So we're going to have that come up, and it's going to, and I can see that it's removed some of the dip in the anomalies. In this one, it's a little bit less removed. It's still, but everything is still pronounced enough that I'm going to get that false alert. So what I'm going to do is I'm going to change my moving window from 10 minutes to 30 minutes. And I can see that, oh, look, it's actually gotten a lot smaller. So if 30 was good, let me go back and put in 60 minutes. And now I've really smoothed it out. I've gotten rid of almost all the anomalous dips. We won't alert. But what I've done is I've negatively affected the window in which I'll be alerted on the real alert. So again, moving average, which is what every other tool uses for a moving window, isn't working for this particular case. So what I'm going to do here is I'm going to get rid of the moving average. I talked about our math, and really what I'm going to do here is I'm going to select moving window, but now I'm going to use, instead of using a moving average, I'm going to use a moving median. When you start working with our functions, one of the other things I wanted to point out is that we also describe what the median is going to do. We can give you an example of how it will affect the data that you're looking at, as well as having the actual source of the actual query itself that it's going to build for you is actually listed here as well. So I'm going to select my moving median. By default, it's set to 10 minutes. And what I can see is right away in the orange line is that it's eliminated almost all of the false dips. So I won't get those false alarms. But what it has done is it's left me a very clear but very quick notification that I've got an outage. So I've only have a limited amount of exposure here, and it's way before I would have been notified by Twitter. Now that I'm happy with my query and I'm happy with how my query looks and setting up an alert, I can create an alert for this. So I'll create an alert. I'm going to turn off the query builder because I want to know if it goes greater than 70%. And that'll be my alert. If I didn't have demo data and I had regular data, I would actually see how many times this would go off in my past history. So I would know right away whether I'm making a noisy alert, something that's going to give me lots of false positives, and I'd see them right here. I've got my different severities, whether it's info, smoke, warn, or severe. I've also got my target list. Now again, this is another set of our integrations, is not only where we can pull data incoming, and I'll show you that in just a second, but this is where we're going to go outbound. I can outbound an alert to email, to pager duty, to even to a web event. So I can actually do a post to the environment, start a script, and with my webhook, and be able to start an automation. You know, scaling in a cloud is different than scaling internally. Internally, I've already paid for all my hardware. It already exists. I don't have to worry about the additional cost. If I'm going to use 30% more resources on one of the major cloud providers, they're going to send me a bill for 30% more as we go forward. So if I have my alerting set up properly, I can make sure that I'm going to do my automation at a very specific time for a specific reason. Now I've got a single condition that we've set up in this particular alert, but I can have multiple conditions. Just like I had multiple query lines in that last chart, I can have 10, 20, 30, as much as I need to narrow down that condition to be as specific as I can in setting up an alert. And that gets rid of your false alerts. Again, using webhooks to start any automation inside your environment is always helpful. So this is another example of how our customers use Wavefront. So we're looking at a series of 50 servers. We actually toned this down a little bit because our customer actually had it somewhere in the area of just under 500 servers. And you can think of these as services or containers or serverless components, serverless functions, whatever you like. We're getting data about the service that's being provided. In this case, we're looking at CPU load for anything with a source that begins with the name cluster. And we're also showing an event. So this event is a code push. So our customers go through this on a regular basis. They're highly DevOps oriented, high speed deployment of code, rapid development as well, being able to understand what's going on inside their environment. But if you look here, I can see that I've got an increase, but I really can't tell how much of an increase. Is it significant? Is it, just a little bit? Is it just a little spiky? So what I'm going to do is just quickly add an average aggregation into this. And what this will quickly allow me to do is turn 50 metrics into a single metric. And then on an average, I can see that I've increased almost 50% utilization. So now I know I have to go back and have a conversation. Is this an expected result of the code push that we put out today? It may or may not be bad, but probably it's not great because, again, otherwise everybody would expect this. Now also, if I'm doing troubleshooting, there's always somebody that says, oh, this happens all the time. Whenever we deploy code, it spikes and then it goes back to normal. Did this last week too. So what I can very easily do is really copy this query. I'm going to turn off my, my builder. And what I'm going to do is just lag this data for a week. So I'm just going to lag it for 7 days. And so now I can compare last week's data with this week's data. And I can see right away during my triage, I can see, oh, we have this huge spike. It's definitely an increase. We did not have this last week. Things were spiky last week, but they were continuously spiky. Not the same thing we saw that happened for the code push today. So again, our customers are regularly looking at, do we roll back the new cluster, or do we roll forward with deploying the new clusters out into production? They're comparing their live code to how it used to work before the new deployment to how it worked last week or the week before. Do they have an issue, so that they can understand very quickly, they move forward or do they roll back? Now, I talked about scale earlier as well. Again, Wavefront, super scalable. What we're looking at is over 1 million metrics in a single chart. Now, we don't actually have 1 million points because I don't have a screen that has 1 million pixels on it. But what we're doing is we're scaling, auto-scaling the data. So I've got 726 pixels or point buckets that we're creating across the chart. And what I'm doing, what the system is automatically doing, is putting 43,000 seconds worth of data into each point bucket. And then it's averaging it to see how things are. Now that's really good. Averages are great. They tell us how things look. We can get a ballpark how it was over time. But if I was doing capacity planning, averages wouldn't cut it for me. I would really need to know what was the maximum utilization to make sure that I could cover everything that we're going to use. So instead of having an average here, what I'm going to do is quickly, I'm just going to switch this to a max, and you'll see how fast this recalculates. And we're recalculating over 1 million points of data. And we've come up with our maximums. So we can see that most of the maximums are fine and we're well within it. But what's interesting, though, is that we've got these 2 big spikes. Now, these spikes are really small in the overall time frame, but because we're looking at maximums and we have all the raw data, we know exactly that yes, this was the high point in April. I can drill into this even further. And because we keep all the raw data, I can see that we have a 7-minute spike, really starting from about here to about here, a 7-minute spike in a period of a year, in a year's worth of data. And we're able to view that all in one shot, all at the same time. So again, always having the data, always having the raw data, being able to get that data in and out of our system very quickly so you can see what you need to very quickly. The last thing I'm going to show before I wrap up, actually, no, I'm going to show a couple of things. I'm sorry. What I first wanted to do is go into integrations to give you an idea of all the things that we can connect to, pull data out of, and also deliver events to. So again, we're not only going to bring in our data and bring the data in from all these different integrations, but we're also going to be able to send alerts, outputs to a variety of systems. We've got over 190 different integrations today. We expect to have 200 by the end of the year, which is right around the corner, if you hadn't noticed. We've got tiles for each one of these, all the web services, even some of all the cloud services, as well as some of the individual services that they supply. So we've got Google, Amazon, Azure. If you want SQL Server within Azure, we've got data for that. We've got a variety of data store integrations, message queue integrations, monitoring tools, operating systems, development, and application instrumentation tools. So again, we've got all the functions for all the libraries for all the Lambda applications as well. So again, you can instrument just about everything. And here's the alert notifications. So our outbounds, whether I'm going to ServiceNow, to other help desks, to Jira, things like that. Authentication, so for single sign-on. And I always love to show this. A couple of our developers have Teslas, and they thought, what a great idea. I have an API in my car. I'm going to pull the metric data in from my car to find out what's going in. So we really can pull data from anything. If there's an API or query language, we can pull the data out of that system to get to the metrics. Each one of the integrations, and I'm just going to drill in to give you an idea how this is I can go into, I'm going to go into my Linux host one here, and it's got an overview which will tell you what it is. The setup covers everything that you need for getting up and running. So we can set up one of those proxies, so you can actually do the proxy installation, and it's got the install for the telegraph agent, which is our preferred agent as well. It's got all the key information that you need. And actually, when you do this, it'll actually put your key in. This is our key, and our key will only work with our system. But again, the ability to be able to drill in and have that already figured out. And then if you need to do the agent install or the proxy install manually, we've got information for that as well. It's very similar in whether you're doing Kubernetes or serverless or anything like that. Again, a full set of instructions on how to set it up, the metrics, the description of the metrics we're going to collect. And again, from each of the cloud services, we collect all the metrics that you have rights to, as well as we have a set of sample dashboards that are available for each one of the integrations. Some have one sample dashboard, as we've seen with this Linux host, or you may have, so when we do our AWS integration, you'll see that we have about 35 different dashboards that are available. So again, depending upon which one you select, we'll have different amount of dashboards for those. The next thing I really wanted to talk about was tracing. So tracing gives you a different view of the environment. I'm going to really move from a metric application view to a process of how I am going to step through my application. So what we've got is a sample application here. This is a t-shirt ordering service, and I'm looking at it from the service point of view. These tiles are all created automatically based on the components that we discover. We support open trace, so that's how we able to discover the individual calls, but we actually go beyond open trace with our own libraries and do a superset by adding in additional metric data about each one of the services that we discover. So we're not only going to be able to tell you how long were we in each service, we can tell you a lot of details about each service automatically. So I know a little bit about this application, and most people spend a ton of time inside the shopping portion of the application. So I'm going to go into that right there first. And so we have request rates, error rates, again, metrics that we're pulling in that you wouldn't be able to have if you didn't have the full set of capabilities that Wavefront gives you. I can see that I've got my duration for a particular, for the shopping app, and I can see that I've got some duration spikes, and I may want to drill into this particular area, and I can see what's going on here, and I can drill down into this as well. So I can also, though, look at my different requests, my top failed requests, and my slowest requests. So I'd really want to go into my order shirts, figure out what's, things are failing, they've already failed, that's not good, but I'll check on that later, but I'm going to go into my slowest requests. And I'm going to pull these up and figure out what's going on inside those requests. And again, I'll be able to go into any particular order that we have a trace on. So here's the overall trace where we started in ordering shirts. And now I can go in and see each span, as we go from component to component. So as I make each call, I'm going from my shopping order shirts to the shopping get, to the styling make shirts, to my styling printing shirts. And I can see that I'm not spending a tremendous amount of time in each one of those. And where I'm spending my most amount of time is in the printing and or my delivery section of my applications. So I can see that's where the majority of time, and then I've got a little bit of time also set up within my packaging. So I can also drill down here, and I'll have some additional metadata about this. So I can drill into my printing app, I can see what the parent is, I can see that this is a gRPC method type application or piece of code. And then what I can also do is I've also automatically generated a printing dashboard. So just like I was looking at the shopping dashboard, I also have the subcomponents have their own dashboards that I can just bring up and be able to drill down and understand what's going on. So again, it allows me to walk through my application, understand where things are spending the most time, where the resources are being chewed up, and figure out how things are going inside my environment. So again, we've got a lot of integrations, being able to bring data in from just about anything to give you that full end-to-end view of your applications, of your environment. Again, looking specifically at applications that are generating mission critical results, because again, that's where you need the performance and the power of Wavefront. Again, tremendous amount, over 190 different integrations today. The real difference is we're cloud native with unrivaled scale and performance, as we talked about. Again, being able to go up to ingestion of 4 million points per second. Never lose data, never roll it up, never consolidate. All the other tools do that because they have storage issues with that. And you wind up, why SaaS? Because again, I don't want to manage that hardware. I don't want to have to build an infrastructure around servers and when I could just get that value add right out of the system. Real-time iterative investigation. You saw me able to copy the data, be able to copy the queries, make changes, go back into the data, send it, do a hot link, send that hot link to one of my coworkers. We talked about intelligent alerting and how important it is to have finite and specific sets of alerts with real actionable alerts. Full stack correlation, being able to connect to everything, and really at the end of it, put it all together, it's really being able to answer smarter questions, understand how your environment is working, and be able to identify the trouble spots as they come up. So that's the end of the session for today. At this point, we'd like to do some questions. Carolyn, have there been any questions inside the Q&A?
All right. So, yep. So if you have any questions, just be sure and type them in the chat box there. One thing I think we ought to mention, yep, as pulling up the slide here, Mike, is we do offer free trials. You can go to wavefront.com and you can sign up. And it will be a full-fledged trial. It has all the different features. You can use your custom metrics, and so you can really try it out. We'd really encourage everyone to do that. We also have great resources on our website and on our blog as well. But if there are any questions coming through, I know, let's see, oh, here we go. Question on pricing, how we do pricing at Wavefront and what our model looks like.
So our model is that we charge at points per second on the ingest side. So we don't charge per user, we don't charge per source, we don't charge per host. In the world of containers and serverless, things are ephemeral. So things aren't going to be around all that time. So charging per object isn't going to work. So we just look at the stream of data coming in and we charge based on the points per second. We also work with our customers during the first couple of months to really tune down their environment, make sure that they're getting the right metrics at the right rate and not getting too many metrics, because you don't need to know for most of your infrastructure every 10 seconds what's happening. For your critical applications, you may need to know certain things at a 10-second increment. But again, points per second really provides a nice fair level of how to charge across the environment.
Another question is asking about the data and how we store data in Wavefront.
So we store data. We're very metric centric. We basically create a set of value key pairs based around metrics and tags. It's in-memory database in the back end for most of the data that you'll use. Older data will get stored off to spinning disk, but that's archived, and still it will only add a couple of seconds to a much larger query. So hopefully that answers. It's Foundation DB if you really want to know the technology in the background, although we've got a lot of proprietary stuff in between to make sure that when you decide to send us 4 million data points per second, we can actually ingest that. So again, we use the Foundation DB as the backend core database, but again, there's a bunch of stuff that makes Wavefront operate as Wavefront does. hopefully that answers the question.
Yeah, I think we have time for maybe one more question if anyone has any other questions. While you're thinking, just again, encourage you to sign up for our trials. Also, just remember we are going to be sending a recording of this webinar presentation out to you tomorrow. So you'll be able to refer back to it. And we do these Q&A sessions monthly. So again, if there's anyone else who wants to sign up or is interested at your companies, definitely have them sign up. But looks like questions are slowing down. So with that, we will just thank Mike for his time today. Really appreciate it. And thank all of you for joining. And happy holidays, everyone. And we'll sign
up for a free trial for Christmas. All right. Have a great rest of your day, everyone.
Bye-bye.
Thanks.